Okay, so we talked about this last week, mutually exclusive and non-mutually exclusive events. And we didn't really use a Venn diagram. I mean, I do a little one, but now we're going to look at it and then extend that into probability, which we did. So this type of question, where it's the number of items in a set, we did Venn diagrams with that back in February. Okay, so now we're just extending to probability, right? So given a deck of 52 cards, calculate the probability of drawing a heart or a spade. So remember, or is the union symbol. So that's probability of heart or spade. Okay. You can find it by adding the probabilities of each together if they are mutually exclusive. Okay. So can you have a heart that is a spade? No. Okay, so that's why these are separated. There's 4 suits in a deck of cards: hearts, spades, clubs, and diamonds. Nothing, that's the suit, right? That's the main part of it. So you can't have a card with 2 suits on it. So it's a straight adding the probabilities together. Okay? So 13 out of 52 plus 13 out of 52, 26 out of 52, which is half the deck. You've got 2 suits out of 4, that's half. So the probability of drawing a heart or a spade is 1/2. You can find that N here means the number of items in that set. So the number of items that are hearts or spades is 26. The number in the deck is 52. Right? So you should go straight from there to this. Okay? You don't have to, like, in terms of work for something like this, you can just do that calculation in your head, right? But that is the work if you needed to show it. Okay? So, just a note there, drawing a heart or drawing a spade, those are mutually exclusive, right? So, and theirs just means when you're doing them, drawing them in general. Those are events, mutually exclusive events. Because you cannot draw a card that satisfies both. Now, a different one, and we did one like this last week, drawing a heart or a 10. So, hearts here, notice these sets are overlapped. Because you can have the 10 of hearts. Okay? So, when we try to find this probability, we add them together, but then we have to subtract the overlap because they are not mutually exclusive. Okay, so the probability of a heart is 13 out of 52. There's 4 10s in a deck, so 4 out of 52. And then we have to subtract the 10 of hearts. So we have to subtract the probability of the intersection of hearts and 10s. Okay, so that would be 1 out of 52. So with that same denominator, that's 17 minus 1 is 16, and we can divide by 4. Okay. If we show the actual numbers here, we can do probabilities, but I'm going to show the actual numbers. So in this hearts circle, we have to have 13 in total, but in the overlap, there's 1 10 of hearts. So this would be 12, and this would be 3. Okay, and then outside that, that's 16, so what's that? 46, 36 would be outside here. Okay. So when we're finding or, remember, I call it the hub. It's everything that's in both circles in total. So 12 plus 1 plus 3 is 16. Okay, again, you don't have to draw a Venn diagram, but we're doing that so you can see the relationship. Okay, so there is that probability. This is for non-mutually exclusive events. So when you're finding the union, you have to subtract the overlap. Because really, you've counted that overlap is in here and in here, so it's counted twice, and you have to subtract one of them. Okay, so note again here, drawing a heart and drawing a 10 are non-mutually exclusive events, as one of the hearts is a 10, therefore there's a common element. So when we talk about the sets, we call them disjoint, right? Sorry, not disjoints in this case. The first ones were disjoint, they're separated. Okay, now there's an overlap. So they're not disjoint sets. Okay, let's let's look at the next one to figure out these ones. It says the chart, use it to help find the answers. So outcome of the first die, this should be a little bit separated. Oh, sorry. So you're rolling 2 die. Okay, so your options for a 6-sided die are 1 through 6. Okay, so here's the first one you roll, here's the second one you roll. So these are the sums of whatever you roll. So there's these possible values, okay, 36 of them. So it says determine the probability of rolling a sum of 11 or a sum of 4. So look for the 11s and the 4s. Okay. So they are mutually exclusive, right? So this will be probability of 11 or a 4. Probability of 11 plus probability of a 4. So that's going to be 236 plus 336 equals 536. Okay, do you have to show all that work? No, you can just tell me it's 536. 1, 2, 3, 4, 5. Or means have all of them, right? Next one, probability of rolling a sum of 8. So I'm just going to erase this. So rolling a sum of 8, or rolling 2 of the same numbers. Sometimes we call them doubles when you're playing a game like Monopoly or something like that. So doubles are when you roll 1 and a 1, or 2 and a 2. So it's all these diagonal entries here. Okay. So if you did it in your head, what would the probability be? Well, you'd have 1, 2, 3, 4, 5, 6, 7, but I already included this. So 6, 7, 8, 9, 10. All right? This one was already included, so we don't want to include it twice. All right? If you did use the formula, then it would be probability of 8 union, I'll call it doubles. Probability of rolling an 8 plus probability of doubles minus the probability of 8 intersection doubles. So probability of an 8 is 3, 4, 5. Right? 1, 2, 3, 4, 5. Doubles is 1, 2, 3, 4, 5, 6. And intersection of 8 and doubles, well, that's when you would have 2 4s, right? So there's one of those. And so you get 10 out of 36, just like if you did it without a formula, right? And that reduces, to 5 over 18. What's the answer to C? No work needed. 1, the whole thing, right? Because all of those sums are either even or odd. You never get a decimal or a fraction. Either out of them, right? So that's a 1. Okay. Okay. These ones not going to use the diagram or anything. Just think about it. Calculate the probability of drawing an ace or a king. Okay, so or probability of ace or king. So it's in here. Can you have an ace that is also a king? No. So you're just adding them together. You can add the probabilities together, or just think about it in your head. How many aces or kings do you have? 4 and 4 is 8 out of your deck of 52. And then reduce it. Okay. If you want to show it separately, you can. Okay, so those are mutually exclusive events. Are the events of drawing a diamond and a face card, are those mutually exclusive? Those separate events? No, they're not. They're going to overlap, right? So you have 13 diamonds in the deck. And how many face cards do you have in a deck of cards? 12. Okay, Jack, Queen, King, for 4 suits. So there's 12. Okay, so 13 plus 12 you might think is, okay, that's 25. But remember, a face card is actually the value, right? It's not a suit. So 3 of these face cards have already been counted in here. Right, so we have 13 diamonds. 3 of them are face cards. And then we have the other face card that we need, which is 9. So 13 plus 9 is 22. What did I say? 22 out of 36, which is 11 over 18. If you want to show the formula, probability of a diamond plus probability of a face card minus probability of the intersection. So 13 out of 52 plus 12 out of 52 minus the 3 out of 52 equals 9. Oh, right, 52, sorry. I was thinking of the dust one. Thank you. So 52, so that's 11 out of 26. Good stuff, thank you. Okay, I think we just, on question 4, I have up Miss McKay twice there, I think. Just cross out one of them. I fixed it for my slide here, but you can fix yours up. So, probability of Ms. McKay doing some gardening on Saturday is 0.6. Probability that she will do schoolwork is 0.5. The probability that she will do neither is 0.3. And it says draw a Venn diagram. So, I'm going to do a big rectangle. With a couple of circles. So here, do you think these are mutually exclusive? No. How do you know that? They add up to more than 1. Okay? 0.6 plus 0.5, right away, that's more than 1. Plus this is really more than 1. So they are not mutually exclusive. So they're going to overlap. So This will be gardening. This will be schoolwork. Okay, so the total probability, if we do a probability Venn diagram, the whole rectangle is 1. Neither is going to be 0.3 out there. Okay, so that means the hub, the or there, has to be 0.7. Okay, and so we need to figure out what's been counted twice. What probability has been counted twice. So we're kind of getting a step ahead, just a sec. Okay, so we've already decided that they are no, they're not mutually exclusive, doesn't overlap. So we want to calculate the probability that I will do at least one of the activities on Saturday. So that means all of this. Okay, so if I know that I'm not going to do the probability that I do neither of them is 0.3, then that means the probability that I will do at least one of them is 0.7. Okay, so it equals 1 minus 0.3. Okay, state the probability that I'll do some gardening but not do any schoolwork. So I want to figure out the rest of the values in here. So there's some space here. Think about it. So the probability of G union S, okay, we know is 0.7. We just calculated that, okay. We also know, so basically 0.7 equals, because these are not mutually exclusive, that's the probability of G plus the probability of S minus the probability of the intersection. Okay. And gardening was 0.6. Schoolwork was 0.5. So we can figure out that overlap. Okay. So this is using a formula. You can do it in your head, right? We know this amount is 0.7. We know the total of 0.5 and 0.6 is 1.1. So subtract them. Okay, so if I bring this over here and bring this to the right, that's going to be 1.1 minus 0.7, and that's equal to 0.4. And then remember, you subtract to get this gardening alone would be 0.6 minus 0.4. Schoolwork alone would be 0.1. Okay? State the probability that I will do some gardening but not do any schoolwork. That's going to be 0.2.